Hi, my name is Snorre Stamnes, and thank you for inviting me. I am a researcher at NASA. I study the atmosphere and ocean from space. I want to share with you a new type of instrument that can revolutionize remote sensing of the atmosphere and ocean from space. It's called a polarimeter. If you haven't heard of it before, that's okay. That's mainly because, until recently, we couldn't easily process polarimeter data. But thanks to advances in AI and machine learning, it is now possible. While I am presenting on behalf of our team at NASA, actually, the satellite polarimeter I am introducing today, called Busan Sat, was built by the Republic of Korea. The Korea Astronomy and Space Science Institute, KASI, Nara Space Technology, and Busan Technopark, sponsored by Busan Metropolitan City. So I would like to especially thank the Maritime Affairs, Agriculture, and Fisheries Bureau, the Ministry of Oceans and Fisheries, Busan Technopark, Busan Metropolitan City, Nara Space Technology, and KASI for their technical excellence and unwavering dedication. I would also like to congratulate everyone on the formation of KASA, the new Korea Aerospace Administration. Space missions are hard, but if we work together, I believe there is no limit to what we can achieve. And I strongly believe that Busan Sat polarimeter measurements, together with AI, will enable significant advances in Earth science, including the potential for first-ever detection of floating ocean plastics from space and first-ever small-sat polarimeter air quality measurements. Polarimetry is the future of passive remote sensing of aerosols, clouds, oceans, and lands, from the ultraviolet to visible light to near-infrared and shortwave infrared radiation. Polarimeters can measure or retrieve significantly more information about aerosol properties because polarimeters are sensitive to the polarization of light at multiple angles and at multiple wavelengths or colors. So by a polarimeter, we mean three things: multiple angles, multiple wavelengths or colors, and polarization state. The combination of these three elements makes the magic happen, or technically speaking, significantly increases the information content of our data. Polarimeters can also retrieve detailed information on liquid water and ice cloud properties, land properties, and ocean surface and subsurface properties. And polarimeters have high synergy with co-located Lidar measurements. I will focus on three polarimeters, colored in red, the NASA Research Scanning Polarimeter, or RSP. In green, the SPEXone and HARP2 polarimeters on PACE. And in blue, Busan Sat, which has several unique capabilities that we will discuss in more detail. We originally developed an algorithm for the NASA Research Scanning Polarimeter, which is a highly capable and accurate airborne polarimeter. This algorithm is called MAPP. Its goal is to retrieve accurate aerosol properties and ocean properties at the same time, so we need to consider the coupled atmosphere-ocean system. Here, we show a fit to multiple angles and wavelengths for both the intensity and degree of linear polarization of the light from RSP. We use neural networks to make processing that data take seconds instead of hours. So polarimetry is an example of how AI can be used for the good of society. More recently, we have adapted this algorithm to the two polarimeters on the NASA PACE mission. The MAPP algorithm is adaptable, written in Python, and makes it easy to train AI models and to use them to process polarimeter data MAPP is the only planned operational algorithm for all instruments on PACE. We used MAPP to quantify the capabilities of Busan-SAT for aerosol and ocean properties for Earth science, including studying the Earth's climate. We showed that Busan-SAT is a highly capable instrument. I now want to give an overview of two new areas where Busan-SAT's unique capabilities can make significant first-ever advances. First, paving the way to quantify and monitor floating plastics in our ocean from space. Second, air quality measurements of PM 2.5 over the Republic of Korea. Also, Busan-SAT data and algorithms are directly relevant to current and future NASA missions with a polarimeter. PACE, which launched earlier this year, and AOS, which is the next flagship Earth science mission. This slide summarizes all of the Busan-SAT partners. On the Republic of Korea side, we have CASA, CASI, Busan Metropolitan City, Busan Technopark, NERA Space Technology, and Pukyong National University. On the US side, we have NASA Langley Research Center and Hampton University. Busan-SAT has many ocean capabilities, but one of the most exciting is the potential to demonstrate the first ever unambiguous detection of floating ocean plastics. Busan-SAT has two features that make this possible. Number one, fine spatial resolution of 1 kilometer by 1 kilometer or better to resolve subpixel variations due to sparse but high-density pockets of floating plastics. Second, hyperangular observation capability, so that we can use the degree of linear polarization to resolve changes in the ocean refractive index due to floating plastics. The presence of plastics pollution is being recognized as an increasingly important issue for the ocean, so we anticipate many organizations and scientists are interested in this product. Busan-SAT can also be the first ever small-sat polarimeter to measure PM 2.5 from space. PM 2.5 quantifies how many harmful particles are present, the kind that can penetrate deep into your lungs, and so it is very important for air quality. Busan-SAT's polarimetry measurements at a fine spatial resolution of 1 kilometer enables neighborhood-scale measurement of PM 2.5. Potential users include Busan Metropolitan City, the Ministry of Environment, and the Environmental Protection Agency. I'm also able to share with you data from the Busan-SAT PolCube airborne experiment. The CASI team, together with Pukyong National University, put together an airborne version of Busan-SAT using the engineering qualification model. They are still working on calibrating the data, but you can see the raw data on the right for the different channels and polarization angles, and how it has very fine resolution and contrast. I was very impressed by how quickly they were able to put this together, and this airborne instrument will be very useful for algorithm development and testing. In summary, Busan-SAT is a highly capable polarimeter that will help pave the way to quantify and monitor floating ocean plastics and air quality from space. The Busan-SAT data and algorithms that we will develop together are directly relevant to NASA missions, including PACE and the future AOS mission. Our goal, provided continued support from our partners and the community, will be to launch in 2025, followed by 1 year of operations. Lastly, I would like to thank this World Ocean Forum. I've had the chance to talk to a number of you about Busan-SAT, and we are all very grateful for your warm encouragement and support. Thank you.